Welcome to the AWK programming language. AWK is a special programming language which looks at the input stream as consisting of records and each record consisting of fields, and then you can write program codes that would operate on each record at a time and also selecting what type of a record should be processed based upon any pattern or condition that you can supply. Though AWK is viewed as a scripting language, it has enough mathematical functions that you could actually use it for some of the routine calculations that you would like to do using the command line environment. And AWK is an abbreviation of the names of three people who developed this language, namely Aho, Weinberger and Kernighan. And AWK has been adopted by the POSIX standard, namely IEEE 1003.1-2008, which is the latest version as of now. And there are many variants of AWK with some enhanced features also, NAWK or GAWK or MAWK and so on. On Linux, what you see would be GAWK or GAWK language, but there will be a symbolic link from AWK to GAWK. Therefore, you could use the programming language with the AWK as the name of the executable. And GAWK has some features that are extended beyond what is defined in POSIX. We do not cover that in this session, but you could look them up using the manual page on GAWK. The execution model of AWK is something that if you understand, then you can actually utilize that for certain tasks which can reduce a lot of programming work for you. Namely, you don't have to open files or close files, you don't have to worry about printing out stuff, and you don't have to keep track of which file you are processing currently, which record you are processing currently, how many fields are there in each record, what happens when you change the field separator. All these tasks are taken care by AWK, so that you can focus on your task, namely to look at the fields and do the processing that you need to do. And it's actually also a very fast language, and we will see at the end of this session that to process millions of records, AWK would take just a couple of seconds. And also AWK can do things that spreadsheets cannot do, and therefore knowing AWK could actually save the day for some of you. Now the input stream is looked at as a set of records, and by default the new line character is used to separate the records, which means that each line in the input stream is a record. However, you can override it and provide any other set of characters as the separator for the record, and then the input stream will be split accordingly. For example, in a HTML document, the new lines do not have any special meaning, so you may want to split it using HTML codes. Now each record is thought of as a sequence of fields, and therefore to split the record into fields you can use a field separator. By default the space character is used as a field separator. You can have multiple spaces that will not affect the number of fields. Such a cleanup is done by AWK directly, and you can also override that by defining any other character as a field separator. In fact, you can even define the field separator using the regular expression, so that it can be picked up from a set of characters that you are providing. So you can give multiple options which can act as a field separator, which is fairly unique for the AWK language. And there are code blocks in any AWK script, and each code block will be executed once for every record which satisfies the pattern that goes with the code block. So if you can understand this concept by using the examples that I am going to show you, then you would view the programming of processing a set of records containing fields very differently compared to traditional way of programming, where you open a file, do some action and close it. And by the nature, the number of records is not relevant, so the AWK programming model would scale quite well, and you don't have to worry about the size of the file because it is processing one record at a time. You can run AWK either directly on the command line using a single line for the script, or you could keep the source code for the script in a separate file and call that file using the -f option for the awk executable. So here is one example where the etc password file contains information on the usernames, their full names, the home directory, and such other information. And you could see that such a file would have colon as the field separator. So what is done by the one line command that is there in the screen is to print the usernames, which will be coming as the first field of every line in the etc password file. And you could also achieve the same thing using the script that is given below, where we are explicitly mentioning that the field separator is colon, and then asking the script to print the first field in the code block, which is executed without any pattern, which means it is executed for every line that is read from the command line. Now let us look at some examples so that you understand the processing of input files using awk. So I have kept together some scripts which I would be sharing with you on the Google Drive for all the students, and you could modify these scripts for your purpose, and these illustrate various features of awk as covered in this particular lecture. So let us look at the first script. So the first example is block example, which is very simple. It just simply does one print statement to illustrate how many times each code block is being processed. So you see there are three code blocks here. This is a pattern and this is the action. And this combination of pattern and action are coming 3 times. 2 times it is coming with a keyword, once with begin keyword, once with the end keyword, and then there is another action code block without any pattern in front of the code block, which means that this will be processed for every line in the input stream. So let us run this, and the file over which we will be running this code is also available. So it is the input file. All .input files are meant for providing some test input for those respective scripts. So it is a very simple input file which I have already kept the line numbers for your reference, and you can see that there are 3 lines, which means that when I run the awk file on this particular input, how many times each code block will run will actually illustrate how awk works. I have already indicated the executable, which is the interpreter for the awk script, as gawk. So I can ask which is awk, or okay, and I can also look at what is that awk, and you can see it's a symbolic link, and you see that ultimately it is being pointing to the gawk only. So I have kept that as the interpreter, and -f option is to tell that the script is coming from a file. So what we do now is to execute the awk file, and we have to follow the script with the file in which the example input is coming. And you see that the begin block has been executed once, and it is coming in the beginning, which means that the begin block is executed before any line from the file is read. And then there are 3 lines that are being read. So for each of those lines, the default action without the pattern in front of the code block is processed once per each line. And then once the file has been read completely, then the end block is processed. So this is the sequence: the begin once, and then as many times as the lines of the input, the code block without any pattern will be processed. After that, the end block will be processed. Now let us test this by doing the same thing in a slightly different manner. So I could pipe the input also using this. So it would have exactly the same outcome. Now I will go ahead and edit the input file to add one more line, and you should see what will happen. So there are 4 lines. So you could say that we now expect the default block to be processed 4 times because there are 4 lines. So for each line it is being processed once. Look at the code. So this is the default block which is processed once per line that has been read, and before the input stream is read, the begin block will be executed, and after the input stream has been completely processed, then the end block is processed. Now in any script you can have as many begins and ends also. They will all work as if you have just given them in separate parts of the same begin block. So that also we could test now. So I would copy the begin block after the last end and say another piece of code for the begin block. Okay, and I will also copy the end block a second time, and I will put it in beginning. Okay, so we now have 2 end blocks and 2 begin blocks and 1 code block. So let us see what would happen with this. So you see that the begin block has been processed. So you have seen the one which is there in the front, and then later the second part of that, and then the default action block is processed 4 times, once per each line. End block which came at the beginning of the script has been processed, after that the last one. So the end blocks are processed in the same sequence that we have given in the file. So this is the first statement which has been processed, and then this statement. So the multiple begin blocks and multiple end blocks are interpreted as if they are portions of the same set of actions that have to be taken at the beginning and at the end of processing the input stream respectively. Now what about the line that is being processed? So we could also look at that. So what we do is clean it up a bit, and this line I would print a variable called $0, which represents the line that is being processed. We don't need the semicolons at the end of every statement unless we want to join multiple statements on a single line. And here you would see that the default action is processed for every line. The line is going to be printed. So you see that every line is being printed here. So I would show you the input as well. So for every line, the default action is being processed, and that's 4 times for the 4 lines respectively, and the begin block and the end block are done just once. So this is the model of execution of AWK language. So you can imagine how we can put it to use when we want to process the records or lines containing fields. So we just came across one variable $0, which represents the entire line or the record that is being processed right at every execution of the action block. So what are the other variables? Let us have a look at them. So here are some variables that are built into the AWK language. So except for those arguments that come with -f and -v options, -v for the variables that are being set and -f for the file name where the script has to be read, except for these, all other arguments applied to the script will be available to the script through the variables argc and argv. Argc tells you the count of the variables that are passed on the shell in the command line. Argv will contain a list of the strings passed as command line arguments, and you can access them from inside the script. Now all the environment variables are also available to the awk scripts via the array environ, and it's an associative array. That means it's a hash, and the name of the variable would be the index, and the value of the variable will be available from the associative array. Now the file name that is currently being processed is available using the variable file name, which means that if you pass on multiple file names on the command line, then each time the execution is moving on to the next file, then the variable file name will also be reflecting the name of the file that is being processed. The field separator, the number of fields in the current record as split by the field separator on that record. How many record are we processing currently? And then what is the output format to be used to print out numbers in a pretty manner? And what is the field separator to be used for the output? And what should be the record separator to print the output? And then if there is any matching of the strings done, then what was the length of the string that is matched? What is the starting point? What is the starting position of that particular matched string? And then what is the separator to be used for the subscripts of the arrays? All these can be customized using built-in variables of awk. And the entire record, as we have just now seen, is available as $0, and then the fields are available as $1, $2, etc. So $10 would refer to the 10th field in the current record that is being processed. So these are the only two variables that have $. Other variables will not have $. In front of their name. So here is a way by which the execution of awk scripts will be happening. So every block would have a pattern and then a procedure containing the code and enclosed by the braces. The pattern can be keywords like begin or end, as we have seen just now. It could be any general expression, or it could be a regular expression, it could be a relational expression, or it could even be a pattern matching expression. And one can also give a range of the records to be processed using a comma. And the procedure is like any code block. You could have things like variable assignment, array assignments, input output commands, and built-in functions, including mathematical functions, and then user defined functions which you can write and even keep in a separate file as a library, and then control loops like for loop, while loop, if loop, and so on. So the entire programming environment is available that you can use in the procedure, and then this procedure will be applied to all those records which match the particular pattern that you are giving in the front. And this pattern is optional, which means that if you don't give, then the code block will be called as a default block and it will be applied to every line in the input stream. And if you have more than one such block, then all of them will be applied in the sequence they appear in the script file. Details of what we have seen for the blocks are repeated here for you to remember. So the begin block would be executed once before the files are read. The end block will be executed once after the files are read, and both of these can come anywhere in the script. They can come multiple times, and they can also contain program code within those blocks. And such program code is typically used to do some initialization of variables, but it could also have anything else that you would like to compute at the beginning of the processing of input stream. Code blocks that come with a pattern, they can have the patterns combined with the logical AND or logical OR or negation operators, and you could also give a range of records that could be processed using a comma. You would have already seen that these blocks are processed for each record every time the pattern evaluates to true, and in case the pattern is empty, then the code block is executed for every record. And as you can see that one need not mention what is a pattern. You could actually just give a set of instructions between braces, and that will be interpreted as a default action that will be performed on every line of the input stream. So there are many operators that are available which make the awk language almost a complete programming language. You have got assignment operators which are given in the sequence of precedence. Then there are logical operators, algebraic operators that will help you to do arithmetic, and relational operators for the strings and for comparison purposes. Operators are elaborated here. You could also have the if then else loop in a succinct form as available in the C language here also. So expression question mark A colon B. If the expression is true, then A will be returned. If it is false, then B will be returned. So such concise notations for conditional expression are also available in awk. The availability of any element in an array can also be tested. So it will be tested against the indices of the array, and you could do a comparison to do a regular expression match. You could also negate that particular regular expression match. You also have the unary operators for arithmetic, such as the plus plus for the increment and minus minus for decrement. You could use it both as a prefix as well as postfix. So you could have plus plus a or a plus plus, and they both will work. And of course, a dollar is for referencing a particular field which is coming from the inbuilt variables. And another special operator is a blank space. So if you have two variables separated by a blank, then it will be interpreted as you wanted to concatenate those two strings. And in case you add 0 to a string, then the string will be interpreted as a number while assigning it to the left hand side. Now the number of functions and commands that are available is quite rich. So you have got the arithmetic operations such as the sine, cos, tan, exponential, log, etc. And then you have got string operations, which are for splitting the strings or getting a substring, converting the case of the characters in the string, and matching a regular expression with the string, and so on. And you also have loops that use the control flow, various type of loops that you have seen in shell scripts. All those are also available in awk. Input output functions are available for printing or to read input from a shell command that is executed in the background, and you also have ability to write your own functions. And bitwise operators are also available for fast execution. So that way the awk language is fairly comprehensive, and if you learn it understanding the way it executes, then you can put it to a very good use. Now let us look at the other examples to illustrate the execution model of awk. So here is a code which tells you how to use the variables. So here the $0 would give you the entire record, that is the whole line that has been read, and FNR would tell you how manyth line are we currently processing, and that line is split according to the default field separator, namely the space, and as per that splitting, how many fields are available in the current record. So you could see these three lines being repeated for every input line, and then these two being done only once at the beginning and at the end respectively. So the input file which contains the records that are being processed is here. So here is the input file. So you have got three lines with three different number of fields, so that we can illustrate that through the output. So let us go ahead and execute that. So when you execute, you can see from here that the begin action was performed at the beginning. After that, we have got the pattern of 3 lines output for every line of the input stream. So here it says that the number of fields is 4. You can see line 1, word 1a, word 1b, word 1b. So you have got, like, there are 4 fields that are being reported, and this is the first line. Now when you come to the second line, you see that here it says that the FNR value is 2 and the number of fields is 3. So that is also seen from here, number of fields is 3. And when you come to the last line, so it says the number of fields is 2. So here you can see the number of fields is 2 and the FNR value is 3. That means it is the third line in the input stream that we are talking about. And then the end action block has been performed. So this is the execution model, and we can then use the input lines to execute the code block as we require. We can look at the patterns based upon which the actions will be taken using the next example. So here is a example where we are using the regular expression in front of the action block. So this is the action block, the first action block. This is the second action block. This is the third action block. This is the end block, and this is the begin block. Okay, so this action block will be performed on all those records which satisfy a pattern matching as mentioned here, which means that it should contain alphabetic characters. So if the line has an alphabetic character, this action will be executed. If the line has alphanumeric characters, then the second action will be executed. If the line has any digits, then the third block will be executed. So what is the example input stream that we are trying it out? So here is the example input file where the first line does not have any digits. So we don't expect the third block to be executed on it. The second one has alphanumeric characters. The third one has mix of all three. And then the last line has only digits, which does not have alphabetical characters, and therefore the first block should not be executed on it. So let us test this out. After the begin block, the record 1 has been executed by two blocks, alpha block and alnum block, that is alphabetical as well as alphanumeric, because the first line has alphabetical characters. Now if you look at the second line, all the three blocks have been executed because it has both alphabetical characters as well as digits. So it would satisfy alpha, alnum as well as digit patterns of character matching. The third block is also similar because it would actually have all the three types of characters in that particular block. Now if you take the last block, then it has only the digits, which means it will be satisfied by alnum or digit. So only those two blocks have been executed. And after this was over, the end block has been executed. So this shows you how you can pick which of the records should be processed by which code block. We have taken the pattern matching to one level further complexity. So instead of trying to match the entire record with the pattern, we are trying to match only the first field. That means that the very first field in the record will be looked at, whether it is a alphabetical character or alphanumeric or digit, and then accordingly the code will be executed. So here the pattern is having a relational match. That is, the first field is matched with the regular expression that we have provided. Input stream that we are trying to test it on is here, where we have got different words in the first field. So I have got only the alphabetical character, and then I have got alphanumeric, and then purely numeric and purely numeric. So you can now test how this will be working out. So you can see that the first record has been processed by alpha and alnum, because you can see that the first line has hello will fit pattern matching with alpha as well as alnum. So it has alphabetical characters, so both will be satisfied. Now look at the second record. The first field is MM22B901. It has both the digits as well as alphabetical characters. So it will be executed by all the three blocks, alpha, alnum as well as digit. Okay. In the third line, 6,36 is the first field, which will fit either with alnum pattern or with the digit pattern. So only those two blocks are being executed. Okay, so only two blocks are being executed for the third record. For the fourth record, you see again only a number is there. So the same way it has been executed by only alnum block as well as digit block. So here you can see that this is the alnum block, and this is a digit block. So which means that only when the first field is alphabetical, alphanumeric or digit or comprised of digits, then the second and third blocks are executed. And if the first field is purely alphabetical characters, then the first block is executed. So we can actually do a comparison on any specific field within that particular record, and then ask the action block to be executed on that particular record. So here we have got one more example where we do not do any pattern matching or comparison, but we actually look at the number of fields in that particular record. So NF corresponds to the number of fields. So in this script we are looking at the number of records, and if the records is more than 2, then the first block is executed here, and if the number of records is less than or equal to, then the second block is executed. Now the field separator is being given in terms of a regular expression where the square brackets tell you what are the different options. So the space, the dot symbol, The semicolon, the colon and the hyphen, all of them are being given. So what is the input stream? You can see that the input stream is such that it has all the different types of field separator. It has got a colon here, it has got a semicolon here, it has got a hyphen here, it has a space here, and it has a dot here in the email address. So depending upon which character you would like to choose, the number of fields will be different. So if I choose all of them, then what happens is that every single word or roll number or pin code or telephone number or parts of the email, all of them will be split, number of fields will be decided accordingly. So if you now run this, you would see that the first line would have 1, 2, 3, 4, 5 records. Okay, the second would have 3, the third one will have again 3, the fourth line would have 3, the fifth line would have again 3. Okay, so what we will do is, now we will edit the script to make the field separator slightly more restrictive. What we would do is, we will not allow the space and the dot as possible options, and you now see that the number of fields have been different. So you can see that the last line is being treated as just one record because the field separator is not having dot as one of the possibilities. Now what I would do is, I will change this to only a space, and you now see that the default field separation now would give you 3 fields for the first line, because there are only 2 spaces between welcome to and then to and awk, and then the second line does not have any space, so only one record. Third line doesn't have any space, it has only hyphens, so only one record. The fourth line has 2 spaces, so there are 3 records, and then the last line has only email address and no space, so therefore it's only one record. So by looking at the input stream, you need to decide what would be the suitable field separator to split the record into the fields as you would desire. Luckily, you can change it during the execution of the script also.